This question is about multivariable chain rule. In case you forgot the multivariable chain rule, there's a way you can still find the answer, which is to just plug everything into W. So since x is s times e to the t, and then z is 4s minus t, and then y is s squared plus 2t, you can just take the derivative of w with respect to s, which is a horrible thing to differentiate. It's like product rule and quotient rule combined. It's not so pleasant. So it's going to be a very long calculation, but after you do this calculation and plug in s equals to 1 and t equals to 0, you will get an answer. It's just more painful, okay? Yeah. So what's the better way to do this? Well, the better way to solve this would be, instead of plugging in everything, we just look at the dependence diagram. Okay, so W is a function of x and then y and z. Okay, so this is the proper solution. Okay, the proper solution is to look at W and notice that W is a function of x and y and z. And if you look at x, x is a function of s and t. It has both s and t, right? So x is a function of s and t. Y is also a function of s and t, because it has s and also t. And z is also a function of s and t. Those are the dependence diagrams. So in this dependence diagram, you're going to look at the pathways where the change of a variable affects the change that you're trying to look at. So what does this mean? This means you want to know how W changes when you change S, right? After all, derivative has the meaning of rate of change. Okay, it looks at how much this quantity W changes when you change S. Right? So you look at different pathways that change of S can bring to change of W, and we see that there's one pathway that goes through X, another one that goes through Y, another one that goes through Z. Okay? And we have to figure out the rate of changes going through each one of them. So first one, when you change the value of S, that's going to change the value of X, right? So change of S is going to bring change in X, and that change is going to bring change in W. Okay? So this much quantity, if you multiply these two, you get the change of W due to the change in S going through this first pathway. Is that okay? Yeah. But that's not the only way that change of S brings change to W. There's another one that goes through Y, right? So the second one is change of W going through Y. And the third one, in the same way, there's one going through Z. And the magic of multivariable calculus is that if you want to know how W changes when you change S, it's the sum of all these changes added together. Okay? So this is the multivariable chain rule. Okay? You always obtain the multivariable chain rule from the dependence diagram. If your dependence diagram changes, the chain rule changes. Okay, so don't try to memorize this, because if you have different dependence diagrams, you'll have a different formula. Okay, so it's always different. So in other words, the skill that you have to acquire is how to start from a given dependence diagram and write down the corresponding chain rule. Okay, so now let's try to do this. These are individually not that bad. If you differentiate W by X, because Z and Y are considered as constants, it simply gives you 1 times Z over Y. That's the derivative of W with respect to X. Now, what is the X differentiated by S? What is this? If you differentiate this by S, you get?
X.
E to the T is considered as a constant, right? So you're just differentiating the S, which just gives you 1. Okay, very easy. Yeah, this is a lot easier than plugging all this into the function and differentiating. That one would be horrible. This is a lot easier. Okay, plus, if you differentiate this by y, well, that's like differentiating 1 over y. So you may have forgotten this formula, but at some point you probably learned this one. So using that and replacing x by y, we get that differentiating this by y, you get negative xz over y squared. Times, if you differentiate this by s, what do you get? What's the derivative of this by s? Constant differentiates to 0?
2s.
2s. Plus, and then when you differentiate this by z, it's just x over y times 1, because derivative of z is 1. And then if you differentiate z by s, what do you get? What do you get if you differentiate this by z? 4, yes. Now you have to plug in s as 1, t as 0. That's what's being asked of you, right? But then realize that because x and y and z are functions of s and t, if you plug in these values, x, y, z will have a value. So you have to figure out those values. So x at 1, 0 means 1 times e to the 0th power, which is 1. Y at 1, 0. Here, I mean, s is 1 and t is 0 because y is s squared plus 2t. This is going to be 1 squared plus 2 times 0, which is 1. Z at 1, 0 is plugging in 1 into s and 0 into t, so you get 4. Okay. So those are the values, and therefore, if you evaluate this at 1, 0, now you just have to plug in those values that we acquired into each one of these. Okay, so z would be 4, right? I don't have to write 1, so 4 over 1. E to the 0th power, because t is 0, plus negative x is 1, z is 4, y is 1, times 2s, but s is 1, right? And then you have x is 1, y is 1, times 4. That's 4. That's minus 8 plus 4. Oh, that's just 0. Okay. So you get that value. Now, if you have some time, my challenge to you is to actually plug these into this function and differentiate that like that without using the multivariable chain rule. Just use the one-dimensional chain rule one variable chain rule that you learned in Calc 1, and you're going to get the same exact answer then.